Hello, everyone, and welcome to AMXL's Packaging Strategies second podcast. The intent of this video is to better understand the nonprofit organization of International Safe Transit Association, otherwise known as ISTA. My name is Paul Larson, and I will be your host. Let me introduce Eric Heiser, Vice President of Standards and Certification, to the table. Welcome, Eric, and thanks for joining us today.
Great to be here, Paul.
Wonderful. So, Eric, can you tell me who is ISTA?
Yeah. So the International Safe Transit Association is the acronym for ISTA. We're a member-driven technical trade association focused on distribution dynamics with a mission of helping people reduce product damage during transportation. We kind of come at this from four different pillars. First is through research. We go out and monitor all the different supply chains around the globe to capture what is happening out there from a perspective of shock, vibration, compression, and temperature and humidity. The second pillar is to leverage that research to build tools for people to better understand how their package could survive that particular supply chain. The primary thing or primary tool that ISTA produces is a test procedure. And through our ANSI accredited, which is the American National Standards Institute, we have a process to take that information, that research, translate it into a test and publish that for companies to better understand, as I said, how their package is going to survive that particular supply chain. So those are two of our pillars. The other two is education, and that can come in a few different forms, but it's really about trying to help people deepen their knowledge in this subject of distribution dynamics. Because a lot of folks are new into the packaging realm. Packaging is not a huge segment that people kind of go to school for or find their way into, so we want to help those people. But also, for those that even have some packaging background, typically distribution dynamics is something that there's an opportunity to deepen their knowledge. So we want to offer resources and education through that. In addition to that education component is we want to bring the community together through forums and symposiums so that we can learn together about the evolving supply chain, the hazards that are present, so that we can figure out how to solve for these problems that are facing all of us in these common channels. And the last pillar is certification. So we want to ensure that laboratories have the proper equipment to execute on these test procedures. In addition, we want to ensure that if someone does follow industry best practices of using the appropriate test and following it correctly, that we can acknowledge that work and certify that work that it was done to those industry best practices. So those are the pillars that ISTA kind of focuses around. And we do that through collaboration with our members and those members exist globally. I'm trying to remember off the top of my head here. We have membership on nearly all the continents around the globe. And it's company-based membership. And so it's really that pulling those people together to solve for those common problems is who ISTA, or the International Safe Transit Association, is, and what our mission is again, as I said, to reduce product damage through transportation.
Fantastic. I greatly appreciate that you shared such good insight to who you are, how you operate, what your North Star, your goals are in that mission statement. So it leads me to my next question of, can you explain how the collaboration between Amazon and ISTA started?
Yeah, so it's 2025 right now, and It was over 10 years ago when the collaboration began, and it was to help. It was through this means or this desire by Amazon to help their vendors prepare for their supply chain. It made perfect sense to collaborate with ISTA, as our mission, as I just stated, is to help people reduce damages. And so we began to look at how things move from where they're manufactured to the front door. We know that this new supply chain, the e-commerce, the direct-to-consumer supply chain, is more complex and different than what had been designed to for many years when people are designing packaging for the traditional brick-and-mortar retail store. Those are a little bit shorter distances. Things ride kind of collected together, stretch wrapped together, unified. And now we're talking about an individual package that needs to go further right to the consumer's doorstep. And so the collaboration was really about helping people understand how things move through your network, setting reasonable levels of what is to be expected of a package like that, and leveraging ISTA's network of subject matter experts to translate those understandings into a test procedure that the vendors can use to evaluate the performance of their packaging prior to going to market, because that's critical that you understand any shortcomings that may be in your design before your customer sees those. And that's why we always talk about testing of, do you want to see the failures, or do you want your customers to see your failures? And so that was the beginnings of the collaboration, is really trying to develop an industry tool for people to be prepared for this new supply chain of direct-to-consumer or e-commerce.
Excellent. It is important. You said the main thing is that we want to reduce that damage to the customer. We want to delight our customers, and we want to do that not just in AMXL, but we want to do that for our sortable network and our non-sort network. And so we have a testing method that we've collaborated on and built, and we've been lucky to see a lot of reduction in damages, but it continues to be organic and continues to need some tweaking here and there. I guess my question would be, what is the test method supposed to simulate in a nutshell?
Yeah, so specific to, and there's a couple procedures that we've collaborated on to account for different types of packaging configurations, but specifically to the ISTA 6 Amazon.com-SIOC test, that is accounting for the journey from receipt at an Amazon FC through to the end consumer. And it casts a pretty wide net. It's looking at, as you alluded, to those smaller sortable items all the way up to those bigger items that may be requiring mechanical movement. And so the test has some different paths within it. And it's really broken down by size, weight, and ultimately what that last mile looks like. So it's either parcel or less than truckload. So we're accounting for that journey, and because different size packages are exposed to different hazards, we need to have those different paths, test paths. And then as we understand those distribution hazards, those touch points, and that's something that I didn't hit on earlier, but when we talk about the traditional brick and mortar, that's 5 to 7 touches that a package sees, right? So unload from a truck, moved with a forklift, stacked. Those are 3 different touches. the e-commerce or the Amazon supply chain is 15 to 20 touches. So there's a lot more going on. There's a lot more sortation going on, and we want to account for all those. And each time those touches happen, there's a force that's introduced to that package. And so we want to recreate those forces and those hazards in a controlled environment in a laboratory. So if you take, for example, a sortable package that's going down a conveyor, and it goes to a transfer chute because it's going to go down because it's going to get loaded into a truck. It's going to slide down that chute and come to rest into another package. And another one's going to come down behind it and ram into it. These are all normal operations that we need to account for. And the force that's exposed is a shock force. Well, instead of trying to ram packages into each other in a laboratory, we're going to recreate that intensity, that force, by using a free fall drop test or free fall drop machine. So again, the test is looking at how it flows, the hazards that are exposed, and then recreating those forces and hazards in a controlled mechanism in a lab so that you can make design iterations, redo that test, and you have a repeatable mechanism of understanding, did your design move you in the right direction? Is that design helping you reduce either a known damage or a potential unknown damage? And so I don't know if that fully captured what you were looking for with regard to what the test is. I mean, it's a big test. There's a lot of pages to it. I know that we get a lot of questions, and you get them too here in the lab, that, well, this seems like a lot. What is all this about? And it is a big test, and it is covering off on a lot of things, but it's because it's accounting for a lot of different products and a lot of different ways that they travel. So ultimately, the test that's specific to your package and product is pretty tailored and pretty specific. It's not quite as overwhelming as what it may seem if you grab the whole test. But the test elements are based on known SOPs within Amazon, field data that's collected and analyzed to ensure that the testing isn't overly onus on the vendors the part, but we're holding them to an account of making sure they're doing their diligence, right? When I talk to people about some of this, I give this very exaggerated analysis or very exaggerated story of wrapping a light bulb in tissue paper, by definition, is packaging it, right? But I think we could all agree that's not sufficient for shipping a package or shipping a light bulb to your house, right? Conversely, the expectation can't be that you have to put that light bulb in a steel box so that everybody can recreate all those horrible YouTube videos that people see out there of kicking and throwing and, bad actors, or in a more realistic sense, that truck that may happen to get into an accident, right? That's above and beyond. So where is that kind of natural line? And that's where doing the research, analyzing that information, and setting appropriate levels comes into play, and all leads to building a test that is, the just right test.
Yeah, and is it just right? You kind of set me up just for my next question, is that I've been fortunate enough to be exposed to the small item testing and the large item testing that I'm doing currently. And I have both ends of the spectrum when working with vendors. Oh my goodness, this test is way too hard. And others are saying, is this really hard enough? Are we really capturing everything that we need to capture to get the product to the customer? So I guess I would ask, the question is, how did you come up with, for example, in the small category, the 17 drops? And does a package really go through 17 drops, or is it more like 9, or is it more like 39? Can you explain that?
Yeah. And so this all ties back to my beginning statement relative to how ISTA structures itself to fulfill its mission of helping people reduce damages during transportation. It's the pillar of research. So we're collecting field data for all these different distribution hazards. Again, the four are shock, vibration, compression, and atmospheric. So we're collecting field data by either sending dummy packages out that have accelerometers in them, or for vehicle vibration, we're mounting data recorders to those vehicles and letting them run for thousands of miles and characterizing all of those events. So relative to shock events, right, we're building packages of different shapes, sizes, and weights and putting data recorders in there and sending them through all the different networks to capture how many drops, and I shouldn't even use the word drops, how many shock events are happening. Because again, right, a package could bump into another package, and that's a force that's happening to it. We're recreating that force through a drop test in the lab. So we're sending out these packages, we're capturing all that information, and then we're looking at it. We target the 90th percentile for looking at that data, again, to kind of weed out those outliers, those really high extreme situations that don't happen very often. But also, there's a whole bunch of really, really small events that happen that are so small that it don't have any kind of significant effect to the packaging's integrity. So we kind of want to filter those out. So through our research and how 17 came to be was looking at all that data and determining that there's actually, in most cases, more than 17 events happening. But if you get rid of those outliers of very, very small stuff, we're talking under 3 inches. So just little taps. And those onesie, twosie, really high anomaly scenarios, you get to 17 impacts. And you'll also notice in the test, most of those impacts are focused around the package when it's in its most stable orientation. And this is primarily for those smaller sortable things. Because when they're riding on a conveyor belt, that conveyor belt naturally wants to make that package lay in its most stable orientation with that center of gravity as low as possible. So as it travels down the conveyor like that, when it does collide into the side of the conveyor belt or into another package, those shock forces are going to be focused around those edges and corners of that package when it's in that stable orientation. Gotcha. So 17 is based on our analysis of field data. That 17 number was originally it's based on original data from early in the 2000s. Last year, we just completed another large study, and that information affirmed that that's still what's going on out there. Norm. Yeah, and you can kind of think about it. For the most part, once a large sorting facility gets established, the handling processes and things stay fairly static. You're still going to use conveyor belts. Packages are still going to come in contact with each other. Efforts are certainly out there to try to reduce and minimize that, but we haven't seen significant decrease in that. So at the end of the day, there's a lot of touches, a lot of bumps, a lot of love going on, but the amount of which that is appreciable is in that 17 range.
Great. Well, I know we're coming up on time, but I did want to ask the question of sustainability and the importance it is here at Amazon, but also how is it influencing decisions at ISTA?
Yeah, that's a great question. Sustainability, I realize, is really important for Amazon, and we find it really important as well. We view sustainability in the lens of product damage. In our eyes, the least sustainable thing you can do is have your product become damaged, because that product goes into the trash, the packaging that it came in goes into the trash, another one's ordered, and sent to you.
Right.
So we understand that it's certainly a challenge to balance some of the elements that go into creating an optimal package, one that meets all your sustainability goals. Balancing material selection, cube optimization to make sure that you're getting it in the smallest pack possible. Right. But all of those can't be forgotten or second to this idea of, can the product make it to the consumer? So we feel that the continual investment into research in the supply chains around the world to help build better and more robust tests, keep them up to date, is going to enable people to achieve their sustainability goals by making optimal packages that are performance based, right? So you're not only flexible into what material selection you want, but you're doing it in a way that still protects the product. So sustainability is really kind of core to who we are and what our mission is. Mm-hmm. And we're very excited that Amazon is, we're naturally aligned in that space, and that the consumer is finally seeing the importance of protecting the product and doing kind of the right thing, and avoiding some of the, and there's still work to be done here, but packaging unfortunately kind of gets the villain role and in kind of the real world, that it's waste and it's not important and it's not necessary. Again, that ISTA views it completely differently. We think packaging is really, really important, but you got to do it responsibly. In one way that you can evaluate whether or not your design is responsible is to test it, to make sure that the product is going to get to the consumer in the best condition possible, so that they're delighted, protects the brand, right? There's total upside to this sustainability objective.
Yeah, fantastic. Thank you so much for sharing that and tying together how Amazon feels about sustainability and the reduction of damages, and we feel that they do correlate together quite nicely. I know we're out of time, but I do have to ask this question. What's next for ISTA? What does the future look like as far as of testing? Are we going to have a magic wand that can predict a pass test based on the package look or product inside? Can you?
Well, we certainly want to leverage technology as much as possible and make it easier to make decisions, because supply chains are becoming longer, more complex. There's more information to kind of parse through. So yeah, we certainly do want to take advantage of technology, and we are doing that. But while having new technology, we're still going to need to rely on our fundamentals of characterizing the supply chain. And we're doing that through looking at global distribution routes, global regions, emerging markets. We're continuing to go out and look at shock and vibration data from all of these places, temperature, humidity data, and then go back and look at the things that are already out there, ensure that they're staying up to date. So that's really what the future is how can we help people make easier and better decisions? But it's all got to be built on research and data. And so we need to go characterize these supply chains and watch them as they evolve, because global commerce is where it's at, and those are some long journeys, and you got to, unfortunately, put some time in to figure out how to optimize your pack.
Fantastic. Hey, Eric, I really appreciate your time coming in here to Amazon and sharing your knowledge, your passion, and wisdom to our company and to those that are listening about who ISTA is, how they can benefit the packaging world and benefit the vendors and ultimately the customers receiving a product as intended. So thank you again for coming in. I'm Paul Larson, and I was your host today, and thank you for being here.
Appreciate it, Paul.
All right, take care.